Welcome to Homework Lib.
For dimethyl sulfone, the dipole moment is 4.4 dB. What are the formal charges on sulfur and oxygen, and which geometry is consistent with those data? That's geometry. Dimethyl sulfone, that's two methyl groups, NSO2. So sulfur has four neighbors: oxygen, oxygen, methyl group, and another methyl group. Formal charges on oxygen are minuses, and since the molecule neutral, formal charge on sulfur is +2. To figure out geometry, we need to look at electron pairs on sulfur. So the valence nuclear charge of sulfur is 6. This is 6 group, and there is one electron from each bond. There are two shared electrons for each bond, and one belongs exclusively to sulfur. So 4 electrons. So +6 minus 4 +2, which corresponds to the formal charge of sulfur. So no lone pairs are there. The charges match without them. So there are 2 electron domains around sulfur, and they're trying to be as far from each other as possible. So the geometry is tetrahedral. So the most polarized bonds, that's between sulfur and oxygen, and between sulfur and oxygen, and they are not linear. It means they add as vectors, and the overall dipole moment is not 0, is actually pretty significant. That's how we add bond dipole moments. And that corresponds to pretty significant dipole moment, which is consistent with the observed one. So tetrahedral geometry, no lone pairs on sulfur, charge +2, negative charges on oxygen, and each oxygen has 3 lone pairs when they have negative charge. The problem is complete.